Okay, what are functions? The key word in functions is what? Fun. That is right, because functions are fun. So if you're bored this weekend, you can look up functions and have some fun. But really, what is a function? We did that in 8th grade. What's a function? Oh, that was perfect. Say it into the mic. No, for real. Come up and say it. I don't care. Say it. Say it. No, you got to say it loud so I can hear you. Really, do it. You probably couldn't hear that, but he said where the X doesn't repeat. That is correct. Where the X does not repeat. How many of y'all remembered that? All right. Show me with your hands what shape a function cannot be. Anybody remember that? You are correct, sir. You are correct, sir, because he made a circle. He made a triangle. You are correct. Because remember that your X's cannot repeat, so that means that on a graph, an X cannot have more than 1 point. All right? Okay, X coordinates, obviously, they cannot repeat, and graphs must pass the vertical line test. That is our notes. One of the popular songs at the time was Taylor Swift's songs, We Are Never Getting Back Together. We never, ever, ever getting back to... It's my singing debut. It's okay. Anyways, but Taylor Swift was teaching us about functions because she's saying, you know what? It's never fun to date your ex twice, and it's not. So if you're dating your ex twice, you're not having fun and you're not a function. It's not a functioning relationship if you date your ex twice. Got it? You will never see that in a math book. Probably not on the internet. That's just my fun way to remember. Okay, moving on. Any questions about this? This was just the words. Okay, for the next things, you actually do not have to draw this graph. You're just going to vote if you think it's a function or not. If you think it is a function, I want you to give me the thumbs up. If you think it's not a function, give me the thumbs down. All right, so for this first one, which is actually the graph of arc sine, that's something you'd see in trig, is this going to be a function or not a function? Show me with your fingers. Good, it's not a function because if you drew a vertical line, it would hit how many times? Twice. It can only hit once. So if it hits twice, not a function. Oh, that's coming up in a second. Okay, for this one right here, show me your fingers. Thumbs up or thumbs down? Okay, most of y'all are saying thumbs up. Let's check. If I drew vertical lines, am I going to hit my graph more than once in each spot? So that means this is a function. All right, this was not a function. Okay, for this one right here, I want you to go ahead, vote yes or no. Is it a function or is it not a function? This one is a function because whenever you draw vertical lines, it doesn't hit more than once. Got it? Okie dokie. Okay, next one. We got some more because these are so much fun. Oops. This one right here. Function or not a function? Show me with your hands. You are correct. Not a function. Because how many times would it hit? Yeah, it hits twice. No, it has to be a vertical. It can't be a dot everywhere around because it's a vertical line straight up and down. Okay, I get what you're saying. All right, B, function or not a function? Show me with your hands. Not a function because it hits at least twice. C, is that a function? Yes or no? Yes. Bam, because it's only going to hit once. So this was no, no, yes. All right, D, is this a function? No, you're right. Because of where? Which part? Is this part of the graph? Would that be considered a function if this is all we had? Yes. Which part makes this graph not a function? Yeah, this one, because that's wherever they connect. Now, once I come over here, though, would it be considered a function? Yeah, but this whole thing is not a function because if it appears at least once, then it's not. Y'all got it? Okay, E, yes or no? No, because of what part? Yeah, the little bitty curvy. That's where it would not be a function. Very good. All right, that's our functions. Okay, we can also see if data represents a function, or these are called relations. And what are we looking for here? Somebody had said it earlier. What cannot repeat? The x coordinates. Do you care if the y's repeat? No. Only the x coordinates cannot show up twice. The same one cannot show up twice. You got it? Okay, so I want you to go ahead and I want you to raise your hand. Not raise your hand. Give me thumbs up if you think it's a function or not for this first problem right here. Very good. It is a function because every x shows up once. So this literally means for every input, there's only one output. Do you remember talking about inputs and outputs? That's the mathematical term or terminology. For every input, there's only one output. Okay, this set of data right here, would this be a function or not a function? Yes, it is a function because for every input, there's only one output. And then down here, is this a function? Yes, because for every one input, there's only one output. So yes. Well, negative 2 is on there twice, but what is the negative 2 though? That's a y. So it can only be your x's. You got it? Yes. Yes. If it's an x twice, it's not a function. That's the only one that matters. So let's say I gave you this one for kicks and giggles. Is this a function or not a function? No. How come? Very good, because the x's repeat. Bueno. All right, moving on. I like this too because this isn't necessarily a chart, but you can still see if certain relations are actually going to be functions or not. Would this be a function? No. How come? What repeats? You got 2 oranges. So that means for each input, do I only have one output? No. I would have 2 outputs here. Okay? Let's look at this table. Is this a function? Yes or no? Oh, it says 2012 at the bottom. Can you see now? So, yes, this is a function. So this was no. This is yes. Okay? Yeah, I don't know why they have those colors. I found that on the internet. Okay, function notation. All right, I want you to go ahead and write this in your notes. This says function notation. And function notation, this is what it looks like. But this is read as f of x or g of x or h of x. A function is basically anything. It could be any letters right here. All right. But normally f, g, and h are your most common. If I wanted to say s of t, that would still be a function. You can have any letters. But normally your f is your most common. And then g and then h. That's how they're going to say it. All right? That is function notation. So if you see a problem on the EOC that says, what is the function notation? It starts off there. Now from last year, we should have remembered this. What is the function notation going to take place of? Which variable? Anybody remember? Yes, the range. So it's actually the y. So instead of writing a y equals blah, 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 you can now write f of x equals blah, blah, blah. Got it? All right, so that's what I said right here, but you don't have to write this down. I'm just letting you know. This is usually written in place of y. So for example, y equals 2x minus 1, or I could say f of x equals 2x minus 1. Means the same thing. Basically, this means, hey, this equation that I have is a function. That's all it's saying. This is going to be a function. That's all it's saying. So it like gives you information about the graph without you even seeing the graph. You know that a vertical line will only pass through once on each part of the graph if we were to graph it. Okay? So if I had the equation for a circle, would it ever have f of x? Why not? Very good, because a circle is not a function, so it's not going to have it. Yes. Nope, but just f of x is the most common. Good question. Okay, so what do you think f of 3 implies? If you saw that on the test, what do you think that would mean? Somebody said 3y. What's another guess? 3 equals x. Any other guesses? 3x. Any other guesses? Yes. 3 is about x. All right, only one person was correct, and that person was my main man, Azzy. He was right. This means x equals 3. You got it? So this means that I would put 3 into my function. So everywhere I have an x, I'm going to put 3 into that function. You got it? So this means your function at 3. So let's go ahead and work this example. Find f of 0 if f of x equals 3x minus 1. So once again, going back to our definition as to what it means, who is 0 going to represent? X. 0 is your x, because this means you're putting 0 into your function. Now, you can do notation that says the function at 0 equals 3 times 0 minus 1. This is just notation. This does not mean f times 0. This is not mathematical. All this is notation telling you, hey, I put 0 into my function. All right? Well, great news. We don't really care. Well, we care, but we don't care when it comes to math. Okay, your final answer would be what? What is 3 times 0? Minus 1. All right, so this actually forms a point. And your point is always x comma y, or your input comma your output, right? So what number did we put into our function? 0. What number did we get out of our function? Bam. That is the point that would be created when you put 0 into your function. Yes. You could still say f of 0 equals negative 1 if you wanted to. If you wanted to carry it down, you could. Some teachers in college want you to carry it down. Some teachers in college are okay if you just keep the equal sign right here. And the reason being is because sometimes students think, well, this means 0. But that does not. This is not f times 0. So it's up to you if you want to keep it or not. Yes, ma'am, in the back. Okay. All right, next one. Go ahead and write this down. Find g of 2 if g of x equals 2x squared minus 3. Okay, so what does this mean, guys? 2 is your who? 2 is the x. That is our input, correct? So this literally means we are going to put 2 into our function g. So we can show function notation. I'm plugging 2 into g equals, very good, 2 times 2 squared minus 3. And then this is just order of operations. What would we do first? You would square it. What is 2 squared? 4. What is 4 times 2? 8 minus 3 is 5. Now, just like our friend Sydney had already asked, she said, do we need to bring down g of 2? If you want to, you can, but do you have to? No. What would be our point then? 2 comma 5. Perfect. Okay. Last one. I love problems like these. And guess who else loves problems like these? College professors. The EOC. All of Miss Fruget's tests love problems like these. All right? I love it. Because it's really testing your knowledge. It's saying, if f is any variable a, what would be my output? So I'm not even giving you really a number. It's like arbitrary. And arbitrary means, any number. So basically, give me a rule that would be true for any value of a. All right, so we're going to say instead of f of x, what are we going to write, friends? F of a equals, now instead of writing x, what do we put in its place? We put a in. Some people get really confused with how this should look, so here's a simple math teacher tip for you. If you want, you can just scratch out where your x's are, and that way you know in my scratch outs is exactly where my a goes. Some of you don't need to see that because you can visually see it, but some of us in here might need to do the scratch outs, and that's okay. So what would I write in this case then? Negative a minus 2a squared. Are these like terms? Are they? No. Yeah, because one's an a and one's an a squared, so they are not like terms. So can you combine them? No, you can't simplify. This is your answer. So this tells me that when I put a into my function, my output will be the value of negative a minus 2a squared. And a, remember, could represent any number. So if I put 3 into this function, the final output would be negative 3 minus 2 times 3 squared. If I put 4 into this function, it would be negative 4 minus 2 times 4 squared. Y'all got it? Yes, sir. I know. Okay, moving on. Okay, this graph right here is basically the temperatures in New York City, and I found this online, so don't tell anyone. Anyways, this is the graph, and this is asking you find f of 1. And they love giving you questions like this. What do you think this means on the graph, find f of 1? What do you think? Very good. Find where x equals 1. So where does x equal 1 at? Yes, 43. Because when x is 1, that's my input. What is my output that matches it? That's your answer. It's basically just the y coordinate on the graph. That's what it means. So what is f of 6? Now we can also get more fun with it. All right, we can say fun things like this, which is what is f of 5 minus f of 4? So what would we need to do in order to find it? Very good. So f of 5 is 59 minus f of 4, which is 57, which is what? 2. Very good, friends. Find f of 3 plus f of 1. What is f of 3? 50. What is f of 1? Which equals 93. Okay, this one is actually leading us up into slope. This is just the fun way that we can write slope if we wanted to. This problem always right here, whenever I first give it to people, this was actually on your pretest if you remember it from the very beginning of the year. This problem looks confusing, but it's so simple. What is f of 2? 53 minus, what is f of 1? Over, this just means I only want to keep it 2 minus 1. Y'all got that? Okay, so let's do the top. What's 53 minus 43? Over 1. And what is 10 over 1? 10. So that's your final answer for that one. Any questions about this graph? Okay, cool. Okay, for this problem, we want to determine which value is greater off of our graph. So f of 11, so that would be f of 11 is what? 5. F of 1 is what? 1 is 22. So who's greater, f of 11 or f of 1? So, bam. Just let it eat. How come I'm not going to say equal to? Was it equal to each other? No. Okay, f of 10 to f of 6. What do y'all think? Is f of 10 greater or is f of 6 greater? F of 6 is greater. Very good, guys. All right, right here, we have f of 5 minus f of 3. Okay, f of 5 minus f of 3. So what is f of 5? 4. What is f of 3? 5. And I wanted f of 5 minus f of 3. So what would that be then? Negative 1. So this is negative 1. All right, what is f of 4? 4. And what is f of 6? 3. So what's 4 minus 3? So who's greater? Now this is just examples that I made. That's why it looks like this, okay? We said that. We said that. Okay, what is the domain of this graph? Domain. What is domain first off? Domain is your x. We learned that in 8th grade. Domain is the x. Now, when we're talking about graphs, though, sometimes it's sufficient enough to, instead of numbers, we can just look at the words. So what is our domain here on this graph? Time. And specifically, what times is our domain? From what to what? From 10 a.m. to 6 p.m. Now, this is a nice question that you could have on the EOC, which says, what does it imply? What does it imply that the domain is from 10 a.m. of the store opening to 6 p.m.? What does that mean? If I said, here's a graph of people in the Dollar General. This is how many people come into the store from 10 a.m. to 6 p.m. What do you think that means? That could be the store's what? Hours. It could open at 10. Because normally you have like what? 2 workers opening it, right? And we'll go ahead and say this store may be in a really shady part of town. So they have an officer at the end that works there too. Okay? But that closes it. What time do they see the most clients? At 1 o'clock. Do you see that? And then where else? What's the second highest time that they're going to see? 2. All right? Do you think this is a successful store, an always busy store? No, because the most people that ever go in is how many? 22. So could this be a graph for Walmart? No. It would be great if only 22 people were in Walmart, because that means that we'd actually be able to get checked out, right? But that doesn't always happen. All right. Yeah, true. If we go early in the morning, we could get checked out. All right. Okay, here's some more vocab words. Okay. And this was just talking about the domain and range, in case y'all didn't know. And our first vocab word that I have already kind of mentioned is relation. Okay. And the relation means that it's a set of ordered pairs. This is kind of a curvy bracket, but that's called set notation. So whenever you're writing ordered pairs, you're going to put it inside of your set notation. Okay? X coordinates, that does not say ACA. That's Miss Fruget's way of saying AKA. Or what does AKA mean? Also known as, because we have to keep math fun somewhat. Alright? Alright, so if the domain is your X coordinates, that means what are we going to put using our set notation, what our domain is? Very good. 3, -1, and 4. But we want to go ahead and do it from least to greatest. So make your little notation. And it's going to be from, what comes first? -1. And then what? And then what? Beautiful. Okay. Our range would be what, guys? The Y. Who's the smallest Y? 2, 5, and then 7. The inverse is basically, and I gave you the math terminology, but it's just the inverse of it. It's just the flip of it, okay? So instead of writing, and once again, you still do set notation. Instead of having 3, 2, you're going to write 2, 3. Instead of -1, 7, you're going to have 7, -1. Instead of 4, 5, you're going to have 5, 4. And that is the inverse. You see that a lot in college. Okay. The next slide you will not have to write. It's just kind of a recap. You definitely saw the next slide in 8th grade, especially on the LEAP. You had specific questions. Before I do switch to it, because some of our friends are still copying down, I want you to raise your hand if you remember what mapping looks like when we're talking about functions. Oh, you all remember. Great. Just kidding. No one remembers. Okay. When I show you, I bet you will. This is what mapping looks like. Now do y'all remember? Yes. Remember, it has the numbers in the circles. So this is just ways that we can show our ordered pairs. I can show them the first way is in a relation. The second way is my XY chart, which we've already seen, right? My third way, and you don't have to write this, my third way is mapping. How did we know if it was a function from mapping last year? What did we just look to see? Yeah, X could only have how many lines coming from each one? 1 line. So would this be a function? Yes. And then plotting points, right? And then whenever we're plotting points, that's just like a graph. Okay? Any questions about that? Yes or no? All right.